Okay, should be recording now.
Okay, great. Begin then. So, welcome to the Unix workshop. I'm Patrick. I'm originally from the UK, and I came to do a PhD in atmospheric sciences here at the University of Arizona. And in terms of Unix experience, I did do a workshop in my undergraduate degree that introduced me to Unix, but that was 10 years ago. And since then, I've just looked things up on a need-to-know basis, really, for my research. And I did feel that there was a bit of a learning curve at the start, but since I would say I've only really learned, say, 3 new things a year. So my main point is that just knowing a few commands, say about 30, got me to the position where I am now, where I think I feel like I know enough just to get by. And I think hopefully this workshop will do the same for you. We've got 2 helpers, Izzy and Emily, if you want to introduce yourselves briefly.
Sure. My name is Izzy, and I am a current master's student at the University of Arizona here, and my department is the microbiology department. And so I started learning Unix about a year and a half ago. I took a data carpentries workshop, and it was like a lot of fun and extremely useful just to use Unix. Like I started using it in my lab work soon after the workshop to try to practice my skills, and I just realized that like it made everything I needed to do so much faster, which like felt very good, and it's like very satisfying to automate your work. So excited for you all to learn.
So hi, it's Emily. I'm postdoc at the University of Arizona, and the reason of why I really start to use Unix command was because I start to have more and more projects about genomic and transcriptomics. So when you start to work on this kind of project, you don't really have the choice. You cannot have a beautiful interface with your data. So,
So thank you for them. So this workshop will talk about the Unix shell initially, and then we'll talk about a bit more about why it's useful. And then we'll go through some essential commands. And if there's time, we'll hopefully write a shell script together. And I'll write out the code along with everybody else in the room. So I will try to explain everything I'm doing on the keyboard. And we really don't want to leave anyone behind. So please raise your hand, your virtual hand on the Zoom, the reactions button. That can do that. As soon as anything on your screen doesn't look like what's on my screen, then go ahead and raise your hand and we'll stop and examine what's going on. And I'll ask questions about the pace of the workshop, and we can again use those Zoom reactions to indicate if I should probably maybe slow down. Because our idea is that it's more important to understand the content than to finish it. So yeah, please feel free to use the chat to ask any questions. One of us instructors will help you to get to an answer, because most likely either I won't have explained it enough, or somebody else will have a similar problem and your question will be beneficial to the whole group. So please ask. And with that, I think I'll share my screen and look over to what we'll do today. Okay, just need to take a few things. Okay. So in the workshop, we'll be introduced to the shell command line. We'll go through some essential operations. We'll navigate the file system using just the shell. And we'll try and get to writing a script at the end. Any Mac or Linux users will already have a Unix shell installed on their machine, so don't worry about that. And then hopefully if you have a Windows machine, you downloaded Git Bash ahead of time in the workshop, and that's what I'll use because I think Windows is probably the most used system. So let's start with a bit of a background because we've done a few of the intros. So what is the Unix shell? So most often we use a graphical user interface to interact with our personal computers. So think of saving a document, you move your mouse to the save icon or select it from the file tab. You're using the mouse to navigate this graphical user interface. And upon clicking, the GUI is then telling the computer to do the operation, which is save. The Unix shell is different to that because we can use it to interact directly with the computer, because essentially the truth is it came before GUIs. And the Unix shell is what's called a command line interface. So that allows you to control your computer using a specific set of commands. And on the command line, you would type a command to tell the computer to save. In that previous example we were talking about, when you're using the mouse to navigate the GUI and you're using it to navigate, you're using it to click, and then the GUI is telling the computer to do some operations. You're bypassing all that and you're just doing it from one line, saying, directly telling the computer what you want it to do. And the Unix shell is both a command line interface, but it's also a scripting language. So you can combine some of these command line operations into a script, and then that can allow repetitive tasks to be done quite fast and automatically. And I would say it's one of the most underrated yet useful tools in computing, because not many people are going to acknowledge Unix shell commands in their papers or anything, but I think they would for R and Python and MATLAB packages. So with that, a few more things on why learn how to use the Unix shell. Kind of similar to what I said before, so you can quickly perform operations on large files, and this is really good for things in my research, like I use a lot of climate data that's huge files that you actually couldn't physically read into your personal computer. So being able to do Unix shell commands is able to like pass it into chunks, and it's not reading it directly into the memory, so that's good. And you can automate repetitive tasks. So providing you've obviously written the right script and with the right commands, it can make quite light work of a task like renaming, say, 100 files. Imagine having to click on every file and then right click to rename, and then typing in the renaming, your new name, and then eventually you're actually performing the renaming. Well, the Unix shell script could do this task in 5 seconds or less. So, and then it also enables the use of high-powered computers elsewhere, whether that be on the server or cloud or on the cloud. So you're interacting remotely with a different machine, and you would definitely need to know how to use the Unix shell in that instance. And it's also been useful, particularly for me, since we've all had to move, some of us would have to move to working from home, using all the shell things instead of a GUI. It uses less bandwidth, so if you haven't got the greatest connection, it's also very useful to know in that instance. So are there any questions on some of the intro we've done so far? If not, we'll move to opening a Unix shell. So on a Windows machine, I'm going to hit the Windows key, which will open the menu, and then I can just type git bash in the search, and if you've installed it, it should start like this. And then for Mac, I think you can use the command button key and spacebar, and that opens the Spotlight search. And then you can just type in terminal. The application from Mac is terminal, and it's the same for Linux. So I'll just reorientate myself here. So we've got the instructions on the right, and then this is the shell on the left, the Unix shell on the left. So if we can get a thumbs up from everybody to say that they were able to open a shell, that would be good. Yeah, great. Okay. we did that. And so when you open the shell, you should be greeted by this prompt. So it's a $, and that indicates that the shell is waiting for input. So up here you can see my cursor, and there's the $, and then there's a line flashing saying we're ready to go, we're ready for the first command. And above it you can see this is my username, and then my machine name, and then I think this is the system that I'm using, the Ling W64. And then this above is base, and that's because I have some Python things going on in the background. But if yours looks different, it's fine. The only things that are really important is to see maybe your username or machine name and this prompt, this $ with the flashing. That means you're good to go. So we'll first run through some really useful commands, and then depending on the time, we'll see if we can group some of them together into a script and perform a task with that script of renaming some files. So first things first, we're going to treat this shell like we've never met it before, and we're going to do some of the basics. So who are you is a good one. So if I type in who am I and then hit enter, we should be told that this is the output underneath the command that we've just typed in, and then it should just return my username. So everybody else should also be able to type in who am I as one word, and then they should also be able to see the return, which is the username underneath. And then another good one to know is the date, time and date. So we can type in date, that's another command, and it should return after hitting enter. It will return this is the current date and time. And that's all inbuilt, these are all inbuilt functions in the shell. And then a really important thing to know is what kind of shell you use. So there are actually different kinds of shells, but the most common is bash, which stands for born again shell, I think, which is based on the creator, I think is somebody's name, like Jason Bourne. Bourne is the name. And then if you want to use if you want to print something to the screen, echo is the command for that. So we can ask the shell the question like, what shell am I using, by typing in echo, and then the $, these brackets, and shell. So the reason for doing the $, and these brackets is because this word shell in capitals is a Unix variable that's part of the Unix shell. So every shell will have its name saved. It'll know what kind of shell it is, and we can ask the question of what shell am I using by using this command, and then we hit enter, and it should give you this back, which is the shell that you're using. So in this case, it would be bash. Some of the other ones are C shell or T shell, I think is another one. But bash is the most common, and they all behave in a very similar way. So they have some differences, but I think the fact that bash is the most common, in most settings when I've ever had to use it, it's always been bash, really. And then we can also use these commands that we've even just done so far. We can use them as variables. So say, like in mathematics, you can assign something to x, like x equals 5, say. You can do the same thing, assigning variables to named objects in the shell. And I think it would be good to do one like this. So learning Unix. We could just put the date in. So we could just say 2021. We could just say it's May, and it's the 17th. We could just do that. But we have just learned that you can use date to tell us what the date is. So instead of just typing it in manually, you can do things like this. You can use the command as a variable. But to do that, you need to use this backtick, this on the keyboard, which on mine, I think on Mac it might be different, but on mine it's just next to the 1 key. And that's needed because if you were to just write date like this, then learning Unix since would just be called this string of characters, DATE. Whereas when you do it like this with the backtick, now the shell is understanding that you mean the date command. So if we then hit enter with this, it then is now read into the memory of the shell. And we can, the same way we ask the shell to print what kind of shell we were using, we can then also use echo to print the variable that we just created. So we can do something like this. So echo and then the $, and then these 2 curly brackets, and then this is our variable name that we just put in. Now it should return the date and time that we assigned learning Unix since as a variable. We can say there, see here, now it's at 15:24. And if we were to just go back and use date to check that it's actually still providing us with the current time and date, you can see that there's a 1 minute difference between this command and when we read it in or assigned it as a variable here. So another thing to do just at this point, I think, which is very useful, is to cycle back through previous commands. And to do that, you can just, when you have your prompt telling you it's ready for a command, you can press the up arrow, and you can use that to cycle back through the previous commands you entered in and hit enter. So you can see that was the one where we asked it to print the variable, and that was the one where we assigned the variable date. That's when we told it, asked what shell we used, the date, and then so all the way back. It's very useful for if you ever make a mistake or something, going back quickly and restating the command you last did. So has everybody followed so far? Everybody got understands what shell they're using? Everybody's using bash. These are all checks, so we can ensure that everything goes smoothly later on. Okay, got some good thumbs up. Great, thank you. And how do you feel about the pace? Am I going a bit fast or is it slow? You can do either. Good on the pace? Okay. Okay, good. So there are some of the commands just to get us started, and now we'll dive in a bit deeper. And you can use ls, which stands for listing the directory. So the L and the S in list. So you can type in ls onto the command line and hit enter, and then it's now listing all the files, the folders, everything within the current place that we are residing in, which I feel like I missed one. Did I miss the PWD? Yeah. Okay, we'll go to that now. So this is listing all the files, all the directories, folders, everything in the current folder that we're in. But we don't know what folder we're in yet. So if I type in PWD, that stands for present working directory. And these are from times before GUIs were invented. So we had different words for things like folder then, and that's why it's used. I'll be using the word directory a lot. This just means folder. And present working directory tells us what folder we're currently in. And so here we have the pathway to the present working directory. And that means I'll explain the output that we see here. So first we have the it's the C drive, isn't it? So, and then we have the one of the users, and then I'm one of the users on this machine in this drive. And if we then do an ls again, we can list all the things. So now we're seeing all the contents of the directory under my username. And that's all here. And we can see things, the blue ones are highlighted here. These are folders, and then something say like desktop or documents, they're all folders or directories. And then the things in white, they're files. And these are going to look different on your machine because you have a different file structure to what I have on my computer. But that's fine. You should still, if you're on your Git bash, the shell should open in the same place. And in this is called your root directory. And then it's the root of your directory tree. So think of it as the tree, and then the roots are the lowest part, and then everything else in the tree, all the branches and all the leaves, they're all your files and documents and folders and everything in that complicated tree pattern. So that's the file directory structure. And we can also do a bit more of an in-depth look into the contents of this directory. We can do that with an argument. So ls is the command to list current directory, but then the argument after it, -l, that's a modifier of your command. So these arguments give a kind of a specific flavor to the command. So they'll change it, they'll modify its operation in some way. So the -l in this case is giving us a more detailed look at the contents of this directory. So if I now hit enter on with this command, we now see a lot more information on the screen. So we're getting the same list of folders and files as before, but everything preceding it is now all those details that we didn't have before. So this here at the beginning is a list of permissions that are associated with the resulting folder, desktop. And essentially they stand for different things, like X is for whether it's executable, as in the file can be executed in a certain manner, and W is for writing, whether you can write a file, and R is for whether you can just read it. And essentially the need to know things here are just, if the more letters there are, the more permissions there are associated. So something like this one has got far fewer permissions attached to it than, so it's more restricted than, say, my documents folder, which is quite open, because me as a user would get into documents a lot. So it's good to have the permissions of that open. And then we can also use ls to look into the contents of a subfolder. So we can look a bit deeper than, say, just the documents folder. We can use it to look within the documents folder at what's going on there. I've saved myself from some typos, but a key thing to introduce here is, so I'm halfway through writing documents, but I'm not the best typer and not the most consistent typer, definitely. So I always use the tab key to autofill the answer. This is a really useful thing. So now I'm only halfway through writing documents, but I can just hit tab and it should fill in the rest of the folder name, because it knows that no other folders within this current directory I'm in start with docum. So I'm going to hit tab now, and now you see it's auto-filled the rest. And that's really useful for some of us messy typers, let's say. But also I think it's just good practice to just keep doing it. And it's also useful now, if you were to press it again, it will show you the contents. Yeah, if you hit it twice, it shows you the contents, but I haven't actually moved. I still have a command on the command line, if you see. So that's another useful thing to do. So that was, I'll go back and do it again. There's ls and then doc, and then I've filled in the rest, and we can just hit enter on here, and that will show us this is the content. But if you notice now, the command line's gone back to the prompt, and I've lost that ls document. And what you can do is go again, Documents and Tab. And then the trick is to do hit Tab twice, and it shows you what's inside that folder, but you haven't actually executed the command yet. So you can actually still see the prompt is flashing at the bottom here and showing me that it's still ready to go. So I could, again, I could go deeper into my file structure. So I can go into, I have a folder where I keep all my work in U of A. And again, I can execute that, and it's showing me all the things I have in my U of A folder. Yeah, I think that's a very useful thing to do. I always end up going, I just hit up to go back to the previous command I just did, and then you can keep going deeper, and you can say, okay, well, I have done some time as a research assistant, and that's why I have an RA folder, and then I'm keep going deeper and deeper into the file structure of my computer. And if I were to go into this one and then do present working directory, it should give me the full pathway of where I'm at in my computer directory system or structure. Well, that's because I was just doing ls, sorry. Okay, I got a bit ahead of myself, but we were just listing the contents of directories, and I was ahead of myself because I was thinking that we were getting to the change directory thing, which is just 2 commands on. But we're still, as the computer told me, I'm still only in my root directory, in my home directory. It's the place where you, when you start a shell session, it's the place you first arrive to. And I want to actually just do one thing first, use some and create something that we'll use for the rest of the workshop. So I'll make a directory in which we can put files, make another folder, that kind of thing. And we can use mkdir. So mk stands for make, and then the dir stands for directory. So together mkdir. And we can then call it, I just have on the right hand side, you can see here, we just need to call it a name. And the important thing is to, between the command and the name, it needs to have a space. So something like Unix workshop. Enter, and then we see there's no return from the computer because we were just making something. And to check that it is there, we'd have to do ls, so listing the directory contents, and then now we should see what we've just created. So hopefully somewhere you can see all the way down here, this one, Unix workshop. That's what we just created. And what we can also do is then go into that directory. So this is just like similar to, say, on a Windows machine, it's in File Explorer, so this icon down here, or on Mac, it's in Finder. You're navigating all the files and folders within your machine. So to do that, like clicking on a folder in Finder or File Explorer, you can change the directory. So we're using CD to do that, standing for change directory. And then we need to give the pathway to where we want to go. So I won't go yet into the Unix workshop directory because there's nothing in there because we just created it. So it might be a bit more useful to go into, say, downloads. And you'll just hopefully. So then we've changed directory, but if you notice, again, we saw no return. There's nothing that came out of the computer here. And we can't necessarily tell that we're in a different directory unless we invoke the command that we just learned, which was present working directory, so pwd. And now we should see, so we've moved from before it just ended at after my username here, and now we have gone into downloads. And we can take a look around in that folder, again, using the listing of the directory ls. So then we've got a whole another set of files, and you can scroll all the way back up to the previous where I entered into that command, it was here. So that's another thing. So when you're scrolling back, be on the lookout for this line. That's very helpful. It's colored, and that tells you when the last command was entered into the command line. So if we go all the way back, keep going, these are all my downloaded files. Hopefully nothing embarrassing. And there we go. That's where I entered in ls, and then this is the beginning of all the files in my downloads folder. So we'll go all the way back down, back to our command line, back to the one where it's empty, and it should be flashing. Yeah. So we looked around in there, and then I think it would be good to actually go back up one directory, which is this command here. And we'll do that, and then we'll go and create a file in that folder we just made called Unix Workshop. You want to go back there, and we want to create a file in that directory just so we've got something to work with. And we can do that using this command called touch. And then this is the name that we'll just give a file. But first things first, we need to actually get to where we want to be. And to do that, we can use, again, change directory. So cd and then space between your command and then your argument, which is ... and that means up one directory. And you could group a lot of these together, and you could go up one directory, and then this would be up 2, and then one more time would be up 3. So that can be useful. But again, you're not really seeing the pathway to your you're not seeing the pathway of your directory tree. So it can be a bit confusing. But again, we've learned that you can use the tab button, the tab key, to see where we are as well. So if I do a double tap on that now on the tab key, that showed me where I would be, or what all the files are 3 directories up. I think that's a bit overkill, because we just want to go back to where we were, which we came down into downloads. And you can actually see on Git Bash, it's quite nice. You actually see the pathway here. But we just want to go up from downloads back to our home directory, which should be here. And then if I do pwd, again, to confirm that I think I know where I am, I think I'm back into my home directory, but pwd is always going to help you confirm that you're back where you think you are. And yeah, I'll go back to just my username folder. We've got a couple of chat. Okay, good. Okay. And so we're in my home directory. And another interesting thing to use is similar to the tab key. So tab was helping us to fill in names of folders and files in our computer that we can remember the first bit of, say, but can't remember the next. So a wildcard is also useful for things like that. And it's the star key. So shift over the letter 8. And it can be used to fill in names of files and folders. So let's just see what's in this directory using our ls command. So you've seen that, and I think it would be useful again to go into downloads. So if you I chose downloads because I feel like everybody in the room would have lots of different file types in their download folder. So I think it would be useful to go into downloads again, and then we can explain what the wildcard really does. So you can use it here in this instance to, along with your list directory command, you can use it to list all the files that end with, say, txt or PDF files or any kind of file type. But you could also use it on the front. So let's first look at all the different files that are in my downloads file. So here we have some PDFs, PNG files. This is a netcdf file down here. There's a text file. That was good. So I'm interested in text files. at the moment, and I want to find out all the text files that are in my downloads folder. So I can command a computer to, oops, I don't know. I can command the computer on the left-hand side, if I click, to list all the files in my downloads that end in with the extension txt. So we typed in ls and then the wildcard saying it, which represents any amount of characters. So it's basically substituting in all these characters for this one. It's substituting all these characters in is done by the wildcard. So we should see that file that I just highlighted, but we should also see all the other text files if they're in there. So it seems like there's just two, this one and this one. But that's okay, that's very powerful and useful. And we could also use the wildcard. I said we could use it as a way to get all the file types, but you could also use it on the, after knowing just say the front of a file name. So now we see this file name where it's a climate issue or environ issue list.txt. So I had a vague memory of, oh, I put a file in here some time ago, but I can't remember what quite the name was. You can do ls and then clim. You could either use tab here, or you can use the wildcard and it should return. I've actually got two here. This is a good instance of that. So I've got one that's a text file, but I also have something that has the first 4 characters the same, but it's a different file extension you can see here. So in this instance, the wildcard is representing either all of this or all of this. And that's why it's a wildcard. It's kind of like a catch-all feature. Shell. Okay, I think we'll move to the next one, which is making a copy of a file, and then we'll also go to moving files around in our file system. Let's copy one of these files, maybe this text file. Let's copy this text file to the folder that we just created, the Unix workshop folder. Now, the Unix workshop folder was up one directory, and it was in my root directory. So we'll have to be careful of that when we are doing this over here. So you can see here the copy command, just cp, standing for copy. It takes 2 arguments. First is the existing file name, so the file you're looking to copy. And then the second argument, because there's a space here, the second argument is the destination and the file name of your copied file. So you can, if you don't use a file name and you just do 2 pathways, it will just copy the file with the same name, but you can also change the file at the same time if you wish. But I think that's a bit overkill. I think we're happy with this file name. That's okay for now. We'll just copy it over. I use tab there to fill in some of the characters, save my bad typing. And then it stopped at the point where there was a difference in those 2 file names. So you can see here, this one, it goes environ_issue, whereas this one is the full word environment. So when I hit tab on CP, like this, CP clim, those 4 characters are similar, and then it tabbed, it auto-filled the rest, and then it said, well, I don't know which of these 2 files you now mean, because there's 2 files that have the same beginning. So you then have to do the unique character, which was the underscore. File name, and now we need to tell the command line where we want to move it to, where we want to make a copy of it. So we can do that by saying up one directory tree, one directory in our directory tree, and then we can use, we're trying to put it in the Unix folder we just created. So we can type in Unix and then the underscore, and then I'm going to use tab to autofill And it also is good in this instance, it's good to like check that you're in the right place you think you are, because if tab doesn't work, then that probably means you're not in the place you think you are. Or it essentially, the shell can't see what you're trying, it can't understand what you're trying to do. It doesn't see that there's any directory called Unix underscore. But I did remember correctly, and we were just up one with the dot dot dash, and then we're trying to go into Unix workshop. So this now, if I hit enter, it should copy that text file into this directory. And there was no problem, there was no response from the computer. It performed the operation okay, but what we can do is go and check that it's there as a sort of gut check. It's useful to do those things at the beginning when you're learning. So we can use our command that we just learned, change directory, and we want to go up one, and we already know that this was the pathway. So we can just do the same. So dot dot dash, and then Unix, and I use the tab to autofill, and then hit enter, and now we should have changed directory to this Unix workshop directory. And we can confirm that again using one from the head of the workshop, DWD, present working directory. Hit enter, we're in that directory, and then let's confirm now that the text file was copied okay. And we can do ls to list the current directory, and we should see it there, as we do. So that was good, and that's a success. Everybody got to that stage. You can give me a thumbs up. Thank you. Great. Okay. Now we're going to move on to a bit more of a risky one. Now there's going to be some words of warning here with this one. RM, it stands for remove, and you can use it to remove files. You can also use it in a way to remove directories as well. But the caution is because it's not like deleting files in File Explorer or on Finder, because on the Unix shell, if you remove a file, it's gone. It's gone forever. You can't get it back. There's nigh on any way to get it back unless you're on some huge computer operated with by a team of people, and they have a way to do that. But I have been I did it myself last week, preparing for the workshop, doing some of my research. I tried to copy and paste 3 files at once. I used RM, and I also copied a file that I didn't want to delete, and I hit enter on it, and then it's gone. And then I spent 15 minutes trying to Google how do you get a removed file back, but you can't. Luckily, it was a Python script, and I had done some checkpoints, so I was able to get it back. But there's been times when I haven't been as lucky as that, and learn from my mistakes. That's what I'm trying to say. And I won't. I won't actually remove this file, but if you were to do it, you can do RM and then the file name, but just be careful. You can also remove directories using rmdir, so it's kind of like the make dir that we did, the mkdir. Well, rmdir is for the directories, but you can only remove an empty directory. So it's kind of like a safety mechanism. You need to empty your directory before you delete it. And I'll leave it at that. I mean, there are some shortcuts, but I wouldn't recommend them because, again, I've deleted whole directories of things. And I think the best advice I could give is if you start a command with RM, then just make sure you read it all the way through and it's doing what you think it's doing. But yeah, okay. And then we can move to WC. So WC does a word count, stands for word count. And it's actually a bit of a misnomer really, because it not only counts the words, it will actually return 3 numbers. It gives you the line count, the word count, and then the character count. And it can do that on this file that we have here. So if we do WC, the word count, and clem which is the start of the text file that we have. I'm going to hit tab, so it autofills the rest of it because I'm lazy and I don't want to type out the whole thing and get it wrong. And then that's there, and we can hit enter, and it should give us our 3 numbers. So it gives us this 33. There are 33 lines in this file. There's 191 words and over 1,200 characters. But this, why is this useful? Well, you can do things like counting. You can just get the line count. I think that's what I found useful in the past. Say for just assessing how long, like if you've got a huge file, it might not be the best idea to display it all to the screen, because all you're going to see is the maximum lines that are on your screen. So the fact that this is 33, I know that it can get 30, I can squeeze in 33 lines here probably. But if this was, say, this number, 1,200, I know that I wouldn't be able to display it all on one page. So it might be more useful to use another way to view that kind of file. So back to word count, we can be a bit more specific and just grab that first number, 32. There we see it's outputted what we want, just doing 33. And the -L is giving us, is the argument that tells it to just give us that line count. And it's particularly useful for things when you use the pipe, which this character is a bit strange. I've only ever used it in Unix command line things, really. I'm not sure if it's ever used in other codes. But it's a very useful one because what it does is it joins 2 commands together. So we might have to do a bit of Googling because it's a bit of a strange command on some computers, but I think it should be on everybody's. It actually should be shift, and then you're looking for this character here, and it should be, I think, above or near the enter key on the right hand side. So shift and the key and the pipe key should give us the pipe on the command line, but on its own, it's not very useful. If I hit enter, it's going to say something. This is a good thing to explain as well. So here we're saying bash is complaining and saying that there's an unexpected token. So it doesn't understand why we just entered the pipe, because on its own, the pipe doesn't do anything because it's just joining 2 commands together. So you need to actually give it the 2 commands to join them. So we can move to this example to explain how the pipe works. So we can, just thinking ahead, I think it would be better to actually do this in our downloads folder, because the downloads folder has all those different file types that I was talking about. So it's going to be more useful to count file types in a directory that has a lot of file types. So let's first just move back to downloads. So I'm using change directory, and then I know I'm in Unix Workshop here. So to go back to, say, my home directory, that's up 1, so ..dash, and now I'm in my home directory, and I can use tab, double hit tab to show me what's in my home directory and confirm. Okay, this has showed, it's asked us a question now, do you want to display all 53 possibilities, yes or no? In this instance, we can say yes. And it showed us all of those files in my downloads file. Downloads? No, I think it's actually in my home directory. But if we did hit no in that instance, could have been better. So let's remember what it was. CD, change directory, up 1, and then if I hit tab, it says, do you want to display all of them? And then we say no, it takes us back to where we were. And it hasn't actually performed the operation yet. So we were trying to move to downloads. So I type in downloads and then tab, and then we can move to downloads. And what we're trying to do is do one useful thing, which is counting the numbers of a specific file type in a directory. So something like this is useful. So let's count all the text files that are within my downloads file. So we've done ls minus ls star and then the text, and that gives us the two files. But then if we I hit enter to get the result, and then if we press up, it takes us back to the command we just entered. And I can do Alt Shift, or I can do Shift and the pipe to get it, and then we can combine it with that word count command we just learnt to get a value of how many file types there are that match this text. We can see 2. Now, I found this really useful in my research because if you have, say, 10 data files, you're trying to maybe set up an array that you'll populate with your data later. This is really good for understanding the dimensions of which your array would need to be. It's also just good for like gut checks when I'm trying to find like the n values, like your sample size number, or how many data points have you got. Well, I always use this command to tell me that. But the pipe is also useful for other things of joining other two commands together. If you, in your Unix careers, you'll see how that can be done in different settings, but we won't go over more of them today because it's kind of specialized and not always kind of down in the weeds of it. And then we'll move to this one, and we're almost there. It's just these 4 for this section. You can also use ls. This is the actual new thing we're introducing. So this it's either greater than or equal or less than sign. But the arrow essentially it ports the output from one of your Unix commands potentially into a file. So instead of just doing ls where it's telling us all of the files that are in my downloads file, what we could do is do ls and then that arrow to tell it to, instead of outputting all of these files and folders onto our screen, which is a mess, we could get it into a file that might be easier to read. So you can do ls and then something like all file names in downloads .txt, because I want it to just be a text file. And then if I hit enter on that, instead of printing them to the screen, it's printed it to this file now. So if we then do ls, we might have to find it in the weeds, but we could be a bit more specific. And that's a good example. So instead of just doing ls where, well, I'm never going to be able to find the file I just created, we can do ls just those text files. That's the only ones I want to see. So let's just look at them. And then we can see here, this is the one I just created using this. Oops. Okay. That's really useful for if you ever print the header of a file or something like that, or something that you want to use time and time again that you would find useful to have as a file. It's really good to invoke this character. And then the final few, grep. It stands for Global Regular Expression. It's a bit of a weird one, but it enables you to search through files for a particular string. So a certain amount of characters or certain type of characters, it can search files for those characters quickly. So if we do an example, we can do grep and then in the string that you're searching for, it has to be in these quotes. And say a common word, just for the example, but I use it for finding like recycling code. So if there's a function that I used in a script at some point and I can remember that I used it and I can remember the name of it, but I can't remember like how all the arguments and how I used it and how it really worked. I use grep, and then inside the quotation marks I would write the piece of code that I can remember, and then you would type the file name of the code. So let's actually do that. So anytime I've imported any packages in, say, a Python script, would be like this. So you're invoking the grep command, you're saying look for this string of characters, import, and then you want it to look in all the Python files. So I'm using the wildcard to say, doesn't matter what the Python file is named, just anything with the extension .py, tell me, search in those files specifically. So then it's given us the whole list of everything that it found. So these are all the times I imported any packages into my Python scripts. You can see that it's printing not only the script that it found the instance of import in, it's also printing the line that was used the word import. So I find that really useful. And then just as another example, if we were to do grep, the initial one I was going to do, if we look for the word the in any of the PDFs, in my downloads, it should also show us that. So this is a bit different because it's the shell has a bit of a harder time reading file types that like PDFs and things like that. So it's just telling us this time that there's matches in this file, but it's still useful to know, okay, well, whatever I'm searching for, it's in these files. And then one that's maybe a bit more useful is one to find file names, because I think you can see from here, it can be quite difficult to completely memorize your whole directory tree. I mean, even the best minds would struggle with that. So I think find is a really good one for that, and you can invoke it. But I think it would be better to go out of find of downloads first. So back into my home directory and use cd --dash to go up one directory. Confirm that I think I know where I am with pwd. And I am in my home directory, and then let's look for some PDFs perhaps. So you use find, and then the argument is name because we're looking for a specific file name. And there's lots of different things you can use find for, but in this instance, I think the most useful one is finding file names. So we're looking for PDFs in my whole directory tree, and this maybe it'll take too long, so I might actually have to cancel out of this one. But it'll process, and I'll talk while it's doing its thinking. So it's searching my whole directory tree, which maybe was a bit of a hard task for it to do, but it should get there eventually. A useful thing to do is, if you're waiting and waiting for a command like this, and you think, oh, maybe I made a mistake, maybe I haven't got enough time to wait for this thing to finish, you can use Control and C, and it will cancel out of the command and it will stop doing what it's doing. But you might still to show what find does, we'll go back to downloads and refine our search a bit more, make it a bit easier for the computer to give us an answer quickly by looking in just a smaller section of my directory tree for, let's look for, I also noticed something that I potentially did wrong. I didn't include here, I didn't include the quotation marks. And that means it didn't understand it was a file name. So this one should return it a bit quicker and should tell us that these are all the Python files in my downloads. So you can see it's important to remember certain things like these commands are good, whereas the ones I type in here are not necessarily always going to be correct. But it's important to be really specific about these things. And then definitely a very valuable one is to find any help on any single command is this line. So for find, that was one we just used. And okay, I said prior to this, I said that we used the argument name to look for file names. Well, what else can file do? Let's find out. And you can find out by using -- and help, and it will tell you all the information you need to know about the command find. So it tells you about its usage. It tells you these in the square brackets, these are all the arguments. And unfortunately, it can be a bit tricky to read some of this a lot of the time because it's not always fit for a wide audience, unfortunately. But yeah, if you ever need help on how things work, there's that. And we also have at the end of this tutorial, there's some extra links which do tell you some help on all the commands that are on the Unix command line. So I think that's the end of one section. That was a bit of a long one. So how's everybody feeling? Everybody following along so far, and they're able to make copy of the files and feeling more comfortable about navigating. We had any questions in the chat? Mm-hmm. Cool. Okay. There's no further questions. Should we move to viewing and changing files? Yeah. Okay, let's recap. I've forgotten where we were. So if I do present working directory, tell us where we are. Okay, we're in downloads. But I think it would be good now to move back to that Unix workshop folder we created. And we can inspect that text file as a kind of demonstration of how to view and change files. Text files are really easy to read on the Unix shell. So I think that would be a good thing to do. So let's navigate there first. We'll need to change our directory. So CD, and we want to go up one from downloads to our home directory, and then we want to go back down into the Unix workshop using tab to autofill. And then we're there, and we should see the text file that we copied over to that place, or hopefully you're also able to copy a different file, perhaps. If not, we can create one. Because we actually missed doing one thing, which was touch. This one. I said we were going to create a text file, and I never actually got to it. So touch is a useful command to just start a file, but without opening it. So we don't always want to have to open a file to begin one. You just want to populate the space with a text file. So to do that, we can use touch. And the actual use of touch, some of these functions have dual purposes. The actual, I think, initial usage for touch is to just update the time it was created or modified. But if the file doesn't actually exist, then it will just create the file for you. So typed in touch, and we've typed in a random file name to give it, and then let's use ls to check that it's been created, and then we can see the one that I copied over, and we can see this empty file that I just created. So now we've got a couple of text files. We can then practice opening, viewing, changing them, and there's a couple of different ways to do that. If you say had a really big file, like I was talking about with the word count command, so say there's a file with 2,000 lines on it, it's too much for your screen to view. And what you can do in that case is just look at the head or the tail, so the start or the end of the file. And I'll use climate this file because I know there's something in there, whereas the random file I just made, I know there's nothing in there. So if we did head on an empty file, we just get nothing back. Whereas if you do head on a file with something in it, it should tell us these are the first 10 lines of what's in that file. And tail will tell us what's in the bottom 10 rows of that file. So it's tail and then space and then the file name that you want to see the end of. So perhaps there's actually not enough lines in the file to show a tail, perhaps, not sure actually. But on a bigger file, maybe it's more useful to show in a different directory, a different file. Yeah, I think it would be better to look at some of those Python scripts I was looking through before, because I know that they have a lot of output in them. So we just navigate back to downloads. So it's up one directory with a .. and then down into downloads. And then we want to look at some of the Python files. And to do that, we can do ls for list. We can use the wildcard to look for any Python files like this. And then now, okay, we have a few different scripts and we can look at the top of them. Say this one. Sense, and then I'm just going to use tab to autofill. Now it's giving us the first 10 lines again, and then let's see if we can see the end of the file. Yeah, so these are just the bottom and the top of the file, and we can be a bit more specific because, well, we've just seen the first 10 lines. Well, what if you want to see more than that? You can use head again, but we can be a bit more specific, and we can do that by invoking some of those arguments that could be added as modifiers to the commands. So -n tells us to list a specific number of rows. So -n, and then how many rows do we want? You can just type in the answer to that argument. So n will require you to put a number after it. So I'm going to put 100, and then again, I'm going to do the same on the, and this time, instead of just showing us the first 10, it should show us the first 100. Yeah. So we can see these are the first 100 lines of that file. All the packages I'm importing, and then something I was doing for the assignment, I don't know. Okay, that's a quick way to look at files, but we can't edit them or change them in that way. That's just if you want to have a brief, quick look. But if you wanted to be a bit more detailed and actually edit the file, you'd have to use a text editor. And there's lots of different text editors, ones with GUIs, so they'll have a graphical user interface, like Word is an example. It's a document processor, but similar, something like Notepad, actually, that's a good example from Windows. That's a text editor, but then there's lots of different ones, Emacs as well. But the most simplest, I think, computationally speaking, not necessarily the simplest to use, is VI. And I think we can use that here to open up a file, edit it, and then if we have time, we'll see if we want to create a script. And to create a script, you have to use a text editor to group all commands that we've seen into one script. So let's just quickly go back up to the Unix workshop directory, and we can list the current directories in ls, and we can now look at this climate or environmental issue text file. So we can use VI, and then that tells it that we want to do open the text editor VI, and then we can use the file name to open it. And now this is, you can see the window is completely changed now. So we no longer have the the prompt, the $, it's not flashing because we've opened a file. And now you can use the arrow keys to navigate the file. So you can see my cursor up here on line 1 is flashing. So that tells us we're on line 1. And also down here is telling us the line number, sorry. And as I move down, you can see those numbers are increasing. And I can just move around and move left and right with the arrows. But this is all just navigating the file. But I can't actually edit it yet. So if I were to type on this line, I'm going to just type the letter A. Nothing happened. Because once you first open VI as a text editor, it opens in a certain mode. It has 2 modes. One is to just view the file, and then one is to edit the file. And to edit the file, you have to move into the edit mode rather than command mode. And to do that, you have to press insert. So to toggle between command mode or edit mode, you press insert to go into edit mode, and then escape to go into command mode. And that's what I've written here, as I'm describing. So these are the insert key and escape key. And the way to tell what you're doing, where you are, is down here in this bottom left corner. You should see it should toggle between insert, that means you're in edit mode, or it should just be blank for command mode. And I'll do that now. So I'm in insert, I'm in edit mode. I'm going to hit escape. Hit escape to go into command mode, and then back into edit mode using insert. Oh, and I accidentally pressed it twice that time. So if you keep pressing insert, it will just cycle between insert and replace. So it's just like as the key does on any other, whenever else you use the insert key on the computer. But yeah, so insert into takes you into edit mode, and then escape takes you out. And if I want to say edit something, like I want to change to add another line, I have to go press insert and to go into edit mode, and then add something I'm just typing now. So yeah, adding another item. And then to quit the text editor, as in to close this text editor and go back to where we were on the command line, you have to be in command mode. So you always, I have to find myself typing, and then you would press escape to go to command mode, and then hit colon, and you can see down here, this is where I'm at here, and colon takes you to, we're trying to quit the text editor and we're trying to save the changes. So the 2 characters to do that is quit with changes. So W tells it with changes and Q is quit. So now we can quit out, and we've gone back. The screen's gone all the way back to where we were before. So on the command line, we have our $, saying, telling us that our command line is ready for a prompt. And you can also go back into the script. You can also save without saving it. You can quit without saving any of the changes. So again, we've entered in, we've hit insert to start editing the text. We can make a change like that. I just did some random characters on there, and then that didn't make sense. So I don't want to save the changes, and I'm going to go out into command mode by pressing escape. And you can see now our bottom left-hand corner is completely blank, indicating I'm in command mode, and hit colon and Q for quit, and then exclamation mark is the shortcut for quitting without saving the changes. That's that. So that's the end of viewing and changing files. Where are we at? How's everybody feeling? I mean, there's another section, but it essentially is taking some of the components that we've learned so far, grouping them together to do the task that I was saying is like one of the useful ways of using the Unix shell. We could use it to rename, say, 100 files in a really quick amount of time. And the next section does go through that, but I think I don't want to overload everybody with information, and I think we've covered a lot already today at this point, enough to get you going and get started with using Unix shell. So it's completely up to everybody in the audience, and we can just shift to the workshop closeout, and we can do a couple more commands and then wrap everybody up. Or if everybody's feeling confident and they're ready for more, we can go through the script. Shouldn't be too complex because we have introduced most of it before. It's just the fact that there's some scripting things that if you're new to that, it could be a lot to see. Whether you think you can do thumbs up or down, or I think there's a tick for green, or even in the chat, or you can talk to me. What did my helpers think as well?
Yeah, let's do the script, Patrick. I think it'll be fun.
Yeah. Okay. Sure. Okay, so there's a couple of things to do before we can dive straight into the script. And first, we need to create some files to perform the name change on first. So we saw how to create this random file here. So you can essentially do a very similar command. We could use our arrow key to go all the way back up to that command that we used. You can see all the ones that I did before, and it was there, touch. But we could actually modify this to, instead of just created just one file, 00. But we could use this to create a sequence of files that goes from 1 to 99. So it will not just create one file this time, it will create 99 files numbered from 1 to 99. And you can, to prove, you can use echo and this to prove that it's just a sequence of numbers. And this is just a way to write a sequence of numbers in from the command line. Think of it as setting up a list or something in Python or any other language, or yeah, it's just setting up a sequence. So if I now enter on that, it should give us the sequence, the numbers 1 to 99, you can see there. And then now if we use it in combination with our touch command, random file, curly brackets from 1 to 91, and then we want that extension to always be text, and then we can hit enter. It hasn't given us anything back, but the command has gone in because there was no complaint, there was no error, and we can list the current directory using ls to see, hopefully, those 99 files. You can see they're all there. So now, okay, I need to be wary that you can need to be wary here now. So I actually made a bit of a mistake, but it's going to be fine, and we can work with it. You can see this file is actually slightly different to this one because we don't have that underscore there. So hopefully I can remember that as we go through the script. And we've learned how to open a file name, open a file. And now this time we want to open a file and we want to start editing it right away. So we can use VI, our text editor, to open a file and begin writing our script. So we can use VI and then space, and then just, if there isn't a file within the directory that you're in with that name, then it will create a new file. But if you're using VI to just open an existing file, then you would type in the existing file name. But we haven't created a file called rename script yet. So that should be fine. And the ending is a bit different. So we've been working with text files with the extension txt. I showed some before with the extension .py, Python files. And for bash, the extension is sh, so the last two letters of bash. So if we then go to that, and we can hit enter, and now again the whole screen's changed and we've gone into a file, and this is what VI looks like. It's a very cost effective in computing terms text editor. So this gray box here is the whole script with a lot of the comments that I will explain. So it's just this line to here. So it's not huge, but we will go through everything slowly together. So the first line of all bash scripts, you need to tell, eventually you're going to run the script. You're going to try and execute it and get it to perform everything within the script. But to tell the shell that it's a bash file and it's a bash script, you need this first line. So as I've written here, it ensures that the shell knows that this is a bash script, not any other shell type, like I was talking about. There's different shell types, and it can therefore interpret it accordingly. So we need to, I pressed a random key then instead of going into edit mode. So I would need to hit insert to first go into edit mode. And now you can see down here at the bottom, we have insert in the bottom left. And now I'm free to type. But I don't want to type that. I want to type in hash and exclamation mark and then bash. And if you remember back to the top of the workshop, when we first did echo and shell, it returned a pathway, and that pathway was, at the end of it was bin and then bash. And so it's essentially taking us to where bash is stored on the file system. So that's our first line. And then you can see every time I enter down into a new line, it's getting rid of these blue tilde signs. I'm going to leave a space, and then I'm going to set up this path to the files. So you know those files we just created, those 1,000 or 100 random files? We want to perform our scripts in that directory. So we first need to tell the script that we want it to perform the rest of the operations in this directory.
Hey, Patrick.
Yeah.
We have a question in the chat that I don't know the answer to. Would you mind checking?
Let's have a look. We can keep it. Is it also return on Mac? What do you mean by to edit? It should be insert on Mac. I think if you haven't got like the extended keyboard that has the home and page up thing, it could be that you have to do Shift and I, something like that. I'd have to Google the exact one, but I try Shift and I to, or Command and I to go between edit and command mode in VI. And then I can't team, then there's a different question from around. Can't seem to type in the commercial anymore. But it worked now. Okay. Good. So we've entered into the script, we've told it that it's going to be a bash script, and then we want to set up the environment. We want to set up the location at which we want to perform our renaming. And we created all those files in the same directory. We could write out the full pathway. Oops, sorry. We could write out the full pathway. But there's also a shortcut. You remember we did, when we first started, I got everybody to create a variable that was learning Unix synths. And we had to use the backtick to use a command as a variable. And we can be a bit more forward or straightforward with the with writing the path. Instead of writing the full long path, we can just use the rectic and pwd, the command present working directory, to tell it that we want to work in this directory. And then from here on, we enter into this loop you can see here. So the way we perform those operations so quickly, the renaming operation, is to take each of those files in the directory and loop over them one by one. So sequentially moving through each numbered file from 1 to 2 to 3 all the way to 99. And this line is doing that. So you would say for a file in this pathway, which we just set here, look for all text files. So anything ending with our wildcard, anything ending in txt. So after this, anything within this loop will now, instead of in place of the word file, it's actually cycling through each individual text file in that directory. So we created those 99. So it will loop through this 100 times, and each time file will be a different file name based on the number. So this is just a standard way to set up a for loop in Unix. You don't have to do anything after, it's just for something, and the file could just be F in this instance. I'll start typing. So yeah, file could just be for F in if you wanted it to be, and then everything's subsequently after that, you'd have to use just F, but we're gonna do the full name and we're gonna use file. And then we've just set up this variable called path to files, and we've set it up to be the current working directory. And that's where we put all those numbered text files and created those random files. And then we want to cycle through each of them. And if this wasn't here, if we didn't put that, it would cycle through all the files. So not just the text files. So we need to put that in. So we just are renaming the text files. And then another standard practice for loops in the Unix shell is to have this line do, because you're performing a doing word, you're performing an operation. So inside there, we are now, you can see the indentation moves over 2 characters. So like this, and that signifies to our eyes and to other readers that we've now gone into this looping system. So remixing is important. And we're going to prepare a few things to do the renaming in a quick way. So the renaming actually is occurring here, but before that we need to do a few things to make the renaming a bit easier and a bit more automated. So we just want to say add in a different word into all the file names. We want to modify them in some way. And you can start trying to change the front end of the file name. But in this instance, we're just going to rename, because it's a bit more complicated and useful. We're going to just rename just before the file extension. So first we want to remove the extension, add in a different word, and then put back in the extension, and then perform that renaming on those 99 files. So this is the way to get just the prefix. That's why I'm creating a new variable called prefix, and there's no spaces here, and that's how we can tell the shell that it's a Unix variable. And we have read in this file into our loop, so we can now call it, and we would want to remove the extension. And to do that, we can use the %, and that splits the file name. So at this point in the script, we've read in the file name, and it should be something like random file and then a number, right? .txt. We want to take off that txt, and we want to put in a different word and then rename it in that way. So this helps us to split the file name, the string that the file name is, the string of characters that is the file name. It helps us to split that string, and that's what the percent sign is doing. And then everything after the percent is you're telling it what to chop off the file name. So we just want to do the extension. We don't want to do like the number. We could do the number, couldn't we? But we don't want to do the number. We just want to chop off the extension. And then we have that, and we're going to use that prefix and modify it slightly, and then use that as the out file name to perform the renaming process. So we can then set up a new variable for the out file name. So again, we want to call it out file and then no spaces, and we're setting up a new variable. So you have to do the $sign and the curly brackets. And then we've just taken off the extension from those text files, and we've called it prefix. So we can use that variable we just created called prefix here. And then outside of the curly brackets, we can add our new extension, and we can add in the word modified .txt. But if you remember, I made a mistake, didn't I? And it was, I'm wondering if it's going to be important. We'll see, and then if it is, I can delete the files that we created and create them properly this time. So that's our prefix and our new out file with the modified addition on the end. And to check that what we're doing is what we think it's doing, we can do a few prints as a kind of gut check. And we can print the initial file name and then the one that we're going to be changing it to. And then we can also then finally perform the actual renaming. We can use MV, which is for moving files, but it's also for creating files. Sorry, it's for moving files, but it's also for renaming files. So you can use MV, and then we can do the initial file name, which was filed because we're going through this loop structure, and each time file will be named something different. And then we can do the outgoing file name. And then to close the loop, we have to write done. And you can see the color of the text changes to match the do. So the two bookends of the loop are do and done. Do at the beginning and done at the end. And then that's everything for the file, for the actual script. So what we can do now is we're still in insert mode, we're still editing, and we can press escape to close out, and we can then save the file in that directory that we're in. And to do that, we can use colon, and then we want to save with the changes, and we want to quit final. If you were to just do W and hit enter, you can see that it says that we've just written a file. So W is for write, and we've written that file, we've saved it, and again, we want to quit out of the file. We want to quit out of the text editor VI by doing the colon to W and then the Q. And now hitting enter, we should go back to here's the command line again, and we can look in the current directory that we're in, and we should now see all those files again, but we should also see this script that we just made. So just do ls, and then we go here. See how it's a different color? And that's because your extension is sh, and we also put in at the beginning of the script, if you remember, we put in this bin and bash line here, and that's told the shell that it's going to be the bash script, and that's been recognized, and that's why I think the colors shifted to green here, whereas these are all just text files with nothing in them, so that's why it's not changing the color of those.
Patrick.
Yeah.
the,
Question in the chat for you about the colors inside the script. MV, who was in yellow. So,
why is MV not in? I think it's just because, so if we go back in, you can use VI and then we can go renaming and then we can go in. So MV is in yellow in this. So sometimes it takes a while for it to update. So really the script won't fully understand, or the shell won't fully understand that this is a bash script until it's closed and written to the file, written to the directory. So as you're editing the first time, it might not have the right colors, but a way to get around that would be to create the file first using touch, and then use VI to come in, write that first line. And if you want to use the colors as a kind of safety mechanism to make sure you feel like you're doing it right, you could close out the script and then open it again. As long as you've saved in this line, it should from then that point on understand what kind of file type it is, and then all the colors should come as a match. This doesn't happen on all machines and everything, but on Git Bash it's useful in that way. Its default settings have this color thing going on, so it can be helpful. But you can also modify all these things, but you would have to probably look that up to work out how to. I'd have to look that up to work out how to change all the colors and coloring and things. You can get unique colors to your own choices if you wish. But I'm just going to close out of this script. I was an insert, wasn't I? I was editing, and now I'm going to hit escape to go into command mode. We didn't make any changes, so I'm not going to save with any changes, and I'm going to go back to using Q with the exclamation mark. So we quit without any changes. And then I know I said I wasn't going to do it, but I think it's a bit safer for me to actually delete these 100 files that I created first, and then remake them, and then we'll run our script and see if it works. So it's good for you to see me delete all these random files. So we can use rm and random, and then I'm going to hit tab to fill in the rest, and I'm going to just use star because I know that everything in this directory is everything that starts with random file. I want to get rid of them all, and we want to remake them. So if we can use the up arrow to cycle back to that touch command where we created them with the sequence, we can then, I can then make up for my initial, which is this. And then we can look at those files again, and now they're all in this better form, in my opinion. And now we can move to executing the script. We ran it, we created it, and now we can work to running it. And to run it, we need to use the command bash to tell it that we want it to be run in the bash shell. And then we can type in rename, and I'm going to use tab to fill in the rest. And then I'm going to hit enter. And hopefully all these files will then see between the numbers and the extension, we'll see a new word. Okay. So this has told me that there's an error because there's a text file called, there's two text files, one called license.txt and one called license_modify.txt, but it couldn't perform the move. It couldn't perform the rename on this license file because I don't have permission. So, you know, at the top of the workshop, we did an ls with the -l, and I showed you all those numbers at the beginning of the detail, or all the letters at the beginning of the details, and I was talking about how some files can be readable, writable, executable. Well, that's all the permissions. So I don't actually have permission to modify this license.txt file. And that's why it actually failed. So the looping actually perhaps was, the loop was trying to read in this license file because it ended with the text extension. even though I didn't have the permissions. It tried to do what we asked it to do, but it couldn't because I just don't have the permissions. But I think the rest should have worked. So if I do ls and enter, no, it didn't. Okay, so that's a good example of the fact that if there's an error in shell, it will just quit out and it won't finish the rest of the command. It's not very robust to if there's any errors or anything. And like some other scripting languages, it's not very robust to if you make a mistake or something, it just throws the error and then it won't continue. So what we can do is I'm going to just remove clim again, because that I think is the reason why, because we have this other file in here that it was created in Notepad, and I'm feeling that has caused problems here. So if I remove it, then I think, and press up arrow to go back to 3 commands, and now we're again going to try and run the script to rename these files. Again, okay, interesting. Well, I'm going to go into first things first. I'm going to see if I'm feeling like the pathway wasn't set correctly at the beginning. So something like feeling like this perhaps wasn't correctly. It's not doing what I thought it was doing. So instead of this, we can do the more longer form where we can substitute in the actual full pathway. And to do that, we can do pwd, and we'll want to copy it. And then use vi to go into the renaming script. And all the way up here. And now, as I need to go into insert mode or edit mode, and then now as we're now going to write out the full pathway name, you need to put the full, any pathways, I think you need to put them in brackets. Oops, it's forgotten the pathway, but I think I can remember it. I think it's this. So now we've made an edit, we've made a change. Hopefully this is going to work, but no guarantees. I hit escape to go out, and I want to save with the changes. And let's try again. Yeah, I still feel like it's not quite understanding where we are. So as a gut check, I think we could, instead of, we can confirm that this path to files is being set up correctly, because it seems like it's not, because in the directory we were just in, there was no license.txt file. So I feel like it's looking in the wrong place. So if we then now do path to, oops. Path files, and so I'm asking it now to just print this variable. Is it getting it right? Perhaps I made a mistake in the assignment of it, but I don't think so. Let's try again with bash and renaming, and then I've got one more idea. If we don't get.
We also have a recommendation from the chat.
Oh yeah, please.
If you want.
Okay. Great. Thank you. So I have a typo in path to files variables missing an S. So, so we open up the script again. So I'm going to actually go back to how it was, because that definitely could have been a mistake from the beginning. So if we go back to how it was, and then try again. Now you can see it's going through, cycling through all of those files, and we asked it to print the original file name, and then this is the new file name you can see here, and it's adding this modified at the end. So let's confirm our work by using ls. Thanks, Renee. And there we can see all the files have changed their names based on that script that we just made. So you can see how quickly that task, imagine trying to rename all those files on using File Explorer or similar, it would have taken me a lot more than the less than 3 seconds it took for it to cycle through all those files. So that kind of is a small demonstration of how powerful the Unix shell can be. And then before you head off for the day, I just want to do a small closeout thing, which is introducing 2 more commands, history and then clear. History is really useful to save your session. So every time you open up a shell, you can save the history from all the commands you've written in. So everything we've done by using the up arrow, we can cycle all the way back through all those commands we did. But say I wanted to save them to a file, we also learned how to do that. But history shows us all those files, and we can see we've done 587 commands, 587 times we hit enter on the command line. And we can then, this is not that useful because it's just printing onto the screen, but we can put it to a file. And we can use tutorial history as a file name. Oops. And now all that print of all those commands we used has now gone into this text file, and we can use renew head as the command to just look at the top of a file. We can check, maybe we just look at the tail, and then we can just see the last 10 commands we did. You can see now it's just outputting those last, or we can use VI to look at the tutorial history text file, and we can see all of them. And going into insert mode, I can navigate around. And close out. That's that. And then if you ever want to clear your screen for whatever reason, some people are interested in doing that, you can use the command clear for privacy things. Maybe it could be useful. You can hit clear, and then it just takes away all of your current output that's on the screen. That's not to say it's gone. History can still be invoked to tell us what was done before. That history will only be erased when you close the Unix session, which we can do now. I think we're ready to wrap up. So I'm going to close it and then close. That's everything. So if there's any more questions or anything, you can add them into this section here. If you click on this, you can now edit our HackMD here yourself, and anybody has access to this, I think, and you can add in your own question here, and I'll look at it over the next week and answer any if you have any, or you can send us, me and any of the instructors, emails with any questions. Hope you enjoyed it. Thank you.
There's a couple questions in the chat.
Okay.
Be able to field. Yeah.
Okay. Thank you very much. Have I used bash scripts to run R scripts? No, but I have used, you can You can use the Unix shell or the command line to run R code or Python code. I sometimes do that. Yeah, I tried running script again. Missing file destination operand after modified text. So that must mean that there's some mistake in the in those two variables that we're setting up. One was for the file, so it can't be that one, but it must be out file. So there could be an issue there, but I think the case in point I was having problems with was because I made a mistake typing. So what I think it would be good if you're having problems, I'd copy and paste this and then paste it into VI, which I think you should be able to do, and then try rerunning, and that should work. If not, send me an email and we can get to the bottom of it there, or just tell me on the HackMD and I'll have another think, and maybe you can send me what script you have so far, and I'll see. Any question from Andrew? I use Bash scripts to run Python scripts. Yeah, it's very powerful and easy. Yeah, yeah, I agree. Yeah, I've used Bash to run some Python commands. It's good for that. It's definitely good for like pre-processing of data and things like that, like the front end before any more, some might say more sophisticated languages like R and Python. Yeah. Yeah, so to open a new text file, it's, yeah, but you have to change the file name inside the two arrow signs, change that to whatever you want. Yeah, something like new script. Yeah. So I think we're probably ready to stop the recording. I'll stop my share. Oops.